So I just finished building a Wordle game in Scratch, and I've been playing my own game quite a bit and realizing just how difficult Wordle is. Like a typical gamer, I'm looking for the easy way out. So I have constructed a Wordle cheater program, a helper app that can help you solve your Wordle problems. So today in this special bonus episode to my Wordle series, I'm going to show you how I coded my helper app. The coding's not too tricky, it's mostly a matter of looking at our huge list of 5-letter words and deleting words that don't fit certain criteria. I'll get into all the details right now. So I'm going to be trying something a little different today. Rather than building this meticulously bit by bit, what I'm going to do is assemble big chunks of code and then kind of walk you through what's happening in them. If you want to freeze frame the screen and build your program along with me, that's fine. But mostly what I'm thinking you should be doing with this tutorial is learning and understanding the code as you watch what I'm doing, and then start trying to think about how you could manipulate this and remix it to make your own word game. This has all kinds of potential to be remixed into games like crossword puzzles or hangman games and things like that as well. You can use this same technology to do all kinds of different word games. So once you figure out my approach here, I think you're going to be able to use it for almost any kind of game. Okay, so I'm inside the finished version of the game file here. You can find the address down below in the comments, or of course you can copy it off the screen right up here. And you can see at the very beginning here, we're dealing with some database work here. So I've got a database called candidates, and it's basically blank at the beginning of the game, but instead of leaving it blank, I put some default text up here, just so that people who are playing the game who click the button to show the list will understand why it's blank. So it's blank because we haven't clicked the solve button yet, and we haven't generated a list of candidates, which is words that might be the answer to your puzzle. The goal is going to be to get the smallest list possible. So we're going to feed a whole bunch of words into this list, thousands of them, and then start deleting the ones that definitely aren't in the puzzle. And we should, at the end, be left with only the words that are candidates to solve the puzzle. Okay, so I actually have two different lists of words here. One of them, which I detailed in my Wordle tutorial, is this gigantic database of 12,000 words from the English language. Now that's every 5-letter word basically within the English language, but so many of them here are words that you would never actually use. So I've pulled up a truncated list here that is actual words that have a potential to show up in a Wordle game. So there's about 2,500 of those as compared to 12,000, and that should make it easier to winnow down this list. There will be an option to play with the bigger database, and I'll show you guys how that works later. So onto the code now. So most of the code in this program, I'm starting in the letters sprite here at the top left, and that sprite contains all the letters of the alphabet colored in yellow and green. And so we're going to be generating a list of up to 5 letters here and assigning each of them a color. Yellow being letters that are correct but in the wrong spot, and green being words that are correct and in the right spot. But we're going to start off with this blank tile, which I've just numbered 0 here. And we're just going to make 5 clones of it across the screen. Each of them is going to have a square ID, and that's a local variable. You can see here, you can see that it's a for this sprite only variable by seeing the fact that there's a colon here before the ID, and that means that each of the clones that I create here will have its own clone ID. All right, so at the beginning we're going to set our clone ID to 0, so that when we go next number, we're going to add 1 to the square ID every time. So when we start at 0, that means our first one is going to end up being a 1, and at the very end we're setting it back to 6 again. So the final object, the master block here that's being used to create these clones, it's going to be hidden later, and it's going to have a clone ID of 6, which means that when we're trying to talk to clones, we can say only give directions to blocks that have the square ID of less than 6. All right, so I've created a custom block here called generate blank letters. That's not strictly speaking necessary. We could have just shoved all this code in between here, but I just like to section off parts of the program that do specific things. So this is the part of the code that's going to generate 5 blocks of code across the screen here. So let's have a look at what's going on here. Let's make this first square visible. So we're going to start by going to the starting position, which is -170, 50, and that'll get it set up here. And then we're going to repeat 5 times, basically creating a clone of myself. So this guy is here, but he's not permanently here. He's going to move across the screen, stamping down a clone in every spot where he goes. So let's go ahead and run this repeat loop here. So that's going to change that square ID so that each guy has a different ID, and then create a clone, and then move 85 pixels to the right here. And so we can run that bit of code now, and you can see it generates a list of 5 different squares across the screen. Perfect. And so at this point, the program's not going to do anything else. This isn't a typical kind of game program where there's a constant loop running around checking to see what you're going to do next. All the action in this particular simulation all happens based on mouse clicks. So the program just stops now and waits for some input, waits for you to click on something and see what happens. We're going to focus on these buttons here, and when I click on this particular sprite, the main thing that's going to happen is going to broadcast a message here called menu, and that's going to send a command to almost every single sprite in the program here, telling them to hide or show depending on where the menu is. So we've got a fairly complex menu system set up in this game where there's 2 different menus that can show up depending on what kind of square you click. And so there's all kinds of broadcasts that are happening back and forth to make different parts of the menu appear or disappear, and in some cases they fade in and fade out as well. So when the sprite is clicked, we're just going to do a little click sound, and then we're going to set a variable called the active square, and that's going to let us know which of these 5 squares we clicked. So if we click in the middle square, that active square is going to be set to square ID 3, and then when we come out of there, we'll know to change this sprite after we select a letter from the alphabet, rather than changing the first or second clone of the letter sprite. All right, so let's go over most of the action in this broadcast menu is over in the menu letters here. So let's have a look at that code right now. And you can see here that when I receive that menu message, we're just getting things set up. We've got our costume switch basically to near the end of the other list so that we can come around when we go next costume, or switch costumes to, it's actually costume plus a couple of settings here, and we'll see that in a second. But so we need our costumes initialized so that when we go switch to the next costume, it will start at the letter A. So we have to start at the end of the list so we can come around to the beginning again. We have an initial letter here, and then we go to a menu called Generate Menu. I did want to show you though that how the rest of this menu is going to disappear basically once we click on the green flag here. You can see that everything else is disappearing. Another screen is going to come up and block this not in Word menu down here, so we don't have to worry about that. But all the menu elements from the main part of the game have all vanished now. And now we can start generating our grid across the screen. So we're basically starting at a start location -200. Let me show you that. There's our Z in the first spot against the alphabet, across the alphabet here. And as we go through this repeat 10 times list, we're going to stamp down 10 letters starting from A to Z here. So let's see what that looks like. So when I repeat 10, we're going to switch costume to costume number +4. So again, we're going to take whatever the costume is. So let's say we're on A, and it's going to advance it by 4, which will get us to the white B. And we're starting on the yellow version of the Z, which when we add 4 to it will of course bring us over to the letter A. So we're switching forward 4 costumes, creating a clone of ourselves, and then jumping over to the next spot. Now these clones aren't going to be visible. Oh, they are here because I have a when I started the clone show. So we're going to need that block here. And so let's try running that code now, and we'll see what happens. We'll click the green flag, click the first letter here, and there we've got our beautiful first 10 letters of the alphabet. All right, and they're all looking perfect. Nothing's happening when we click them yet. So let's carry on with the rest of the alphabet. So we've got our reference object hidden off the side of the screen here. We're going to grab that with code and bring it back to the left side, back to -200. Move it down a layer to a Y -60 lower than currently, which will bring it over to the next row. And then we're going to stamp down another 10 letters. And so I could have put this in a big nested loop, but since we're only doing it twice, it didn't seem worth the effort. So I'm just going to repeat the same code over again here, and this is identical to what was above. And you can see now that we've generated a second list here, a second row of the list here. That'll take us all the way up to T. And then we got the same thing happening for the last row, but we don't have 10 letters. We only have 6 letters left in the alphabet. So we're going to then create that last row here with a loop of 6 objects. From there, we also do want to generate one last block, and that is this default block that is going to tell us, allow us to blank out the letters if we need them to be. So we're going to switch costume to that default and drop a clone of that down, and then we'll be done with our master menu letters object here, and then we can hide it and carry on. So let's try generating that alphabet list one more time. We'll click the green flag and click one of these letters. And you can see that now we also have the default square here that will allow us to blank stuff out. Okay, so again, the program's frozen. Nothing's going to happen here until we click on something. So we're going to have to grab a when this sprite clicked. And we're going to send the information about which of these sprites was clicked back to the main letter so that it can populate that slot with the letter that we've clicked. So how do we go about doing that? Well, let's go grab a when this sprite clicked, and we'll just do a little interface element, a little click sound here. And then we're going to hide this menu again. So I'm going to broadcast a message here that says hide menu. That's going to make these letters disappear and also make other interface elements show so that we're back on our main screen again. And we'll get to that in a little bit. So what we do want to record before we leave the screen though is which of these squares we've clicked. So when it's clicked, we're going to get it to do a little if-else statement here. We're going to say if I'm wearing costume number 1, which means I've clicked this last guy. So it's just checking which costume am I clicking on here. So if I'm wearing the first costume, which is this one here, then we can fill that block in with a blank square, and we'll know to do that. Otherwise, we'll want to fill it in with the name of the square that we're wearing here. So we're going to take the this variable called letter to add, and it's going to be 1 for now, but we're going to set it to the costume name plus the number 2. So we're going to be wearing a white costume by default here. So the white costume has the letter name in it, letter A in this case, without a number on it. So when we add an A2, it will know that the costume it's supposed to wear is the yellow version of the letter A costume. So we're going to set that letter to add to the name of the costume that you clicked plus the number 2. All right, so when we get back here again, we're going to want to hide this menu, which is what happens here. And then we want to show those letters that we generated before. They're hidden right now. Let's make them show again. So when I receive that hide menu button, that's going to tell us to show the main interface again. And so you can see that I've got an if statement here, and this is again where I'm going to use that square ID is less than 6. Remember, we stamped the main object, the one that's not interactive in this game, that's hidden right now with the number 6. So if I put an if statement here that says if square ID is less than 6, that will only activate the squares that are clones. So there we go. And that will show them all. So now let's go through this one more time. We'll click the letter A, and now our list is appearing again. Beautiful. So now we need to change the costume of the object that we clicked to match that variable that we just looked at over in menu letters, letter to add. So if square ID equals active square, remember that was the number that we clicked, then we're going to switch costume to the letter to add, which in this case is going to be A2. So let's try that now. We'll click a letter, click the letter A, and you'd see that Beautiful, we've got the letter A appearing here, and this works for any of these slots here. So if I click the middle slot, for example, I can click the letter D, and that fills that up with a D. And let's fill the last up here with a T. And if we want to erase any of these letters, as I said, we can click on it, then click on the default, and that'll bring it back to blank again. So the letters that we're creating here are by default yellow, but there are times in the game, if you've played Wordle before, that you'll know that you want to change them to green. And sometimes if you hit the wrong button, you might want to change it back to yellow. So I've had to create an interface element here that allows us to toggle the letters that we've picked here between yellow and green. Now I've created a couple of little costumes here that I want to show you right now. Just little squares. There's a yellow one, the green one, and a yellow one here. And we're going to place one of them underneath each one of these big squares. And that will allow us to toggle those colors around. And it's not too complicated at all. Let's go have a look at the code for the green squares here. You can see that when I get the start menu here at the start of the game, we're going to set it up in a default position here. Which is right over around the left side here. And we've got a unique ID number for both the green squares and the yellow squares. In this case, it's green square ID, and it's a local variable. Then we're just going to plunk some clones down here. They're 85 pixels apart, the same as the main menu. And yeah, and then our main object's going to hide here. And we're going to set the parent object's ID to 6 again, so that we don't accidentally click on it. So let's have a look at what that looks like now. There we go. And it's over on the right hand side. We're going to generate the yellow blocks over right beside on this side here, and then it'll all look nice and tidy. Okay, so again, nothing's happening in the program until we actually click on one of these squares. What's going to happen when we click it? Well, we're going to play a little interface sound to confirm that we clicked it. Then we're going to use that active square again to figure out which of the 5 squares here that we're representing is the one that got clicked. So we're going to set that active square to the green square ID that we just set. And then we're going to send a broadcast out called change to green. And that's going to be received by our letter sprite. And it's going to take that active square information and enter it at that point. So let's go back to the letters here and we'll have a look at that bit of code. Here's change to green. And so we're coming back here with that active square ID. So let's say it's the middle square that we've pressed. That's 3, right? So if square ID equals 3, this message is being received by all the clones, but it's only going to be acted on by the clone that has a square ID of 3. And then it's going to switch its costume to, now we're doing a little join here. So we're taking the costume name, but we're only taking letter 1 of the costume name because the costume name might be A2 or A3 or whatever. And we're going to join the first letter of the costume, which is only A, and we're going to add a 3 to it. And that will, of course, make costume A3, which just happens to be our green square. So let's give that a try now. I'm going to assign a letter here, A. And then when we click on the green square here, it flips over to green. Beautiful. Now, if you do click one of these and it's blank, it's going to default to the letter A because it doesn't know what the heck to do. That's no big deal, though. If you do that accidentally, you can always blank it out this way. Okay, so the process is exactly the same for our yellow square here. And let's go ahead and just quickly blast through that. So we've got our yellow square here. It's being positioned in a slightly different X location. And we have a different local variable here, yellow square ID, but everything else here is identical. Now, we do want to show and hide this with the other menus. So that's why in both of these cases here, I have it hiding when I show my letters menu and reappearing again. And because we're talking about clones, we have to use this if statement here. And so it's reappearing again when our menu reappears. So, and I believe I have that hooked up here. Yes, I do. Okay. So I think we can go ahead and click the green flag here. And yes, and now we have our yellow menu items in place here. And you can see that they disappear when I get into this other menu and then reappear when I'm back here again. And the code is pretty much identical for what happens when you click these guys, which is we play a sound, we set the active square to match the ID that we stamped up here, and then we broadcast a change to yellow message. And in this case, it's the same code, except identical to the code above it, except we're gonna join the letter 2 to that costume letter so that it knows to wear the yellow costume. And you can see that in action here. We can go back and forth now between green and yellow. Oop, that slipped around a little bit. That'll reposition itself as soon as I do this. So yeah, that's working quite nicely now. And it's true of all the letters here. We can do it here as well, just a test. And let's do it to this one as well, just as a while we're at it. There we go. So everything's working beautifully. So then now that we're able to add some data to our list here by clicking on these 5 objects and manipulating them, we can take the information we've gathered and apply it to our word list and see if we can winnow down our list of candidates and figure out what our winning word is. To activate that process, we're going to use the solve button, which is another sprite that you can see right here. I've created 2 costumes for it, just a simple rollover effect here that's going to make it turn gray when our mouse moves over it. And you can see what that looks like right over here. If touching mouse pointer, it's going to switch to the second costume, and if not, you can see that it's going to go back to its default costume. And so that just gives you a little extra feedback here to show you that this is clickable, and that's particularly important for this solve command here, which I've adorned with a little light bulb, because this is pivotal to making the simulation work, of course. So when we click this sprite to try and solve the puzzle, we're going to be doing a bunch of stuff. Starting off, we're going to hide this list of candidates. It's going to appear and disappear as the game continues, but we don't want it visible right now while we're deleting it and adding some new elements to it. So we're going to hide it for a little bit. We're going to play a little ingestion sound here that tells us that we're processing the data. Then we're going to delete everything from a list here called selected letters. Now, I haven't talked about selected letters yet, but it's a list that's just keeping track of what the identity of all 5 of these squares is. So we're going to start off by deleting everything on that list, and then we're going to populate it in a second over on the letter sprite. We're going to do that after we broadcast a message. So this is what's going to take us back to the letter sprite. We're going to broadcast a message here called evaluate. And then we're going to wait for an answer, basically. We're going to watch the program go through all its calculations, figure out what words work and what don't, and then it's going to spit out a list out, which is going to be controlled by this sprite later on. So it's going to sit here and wait for the letter sprite to have a look at what's happening and process all the information. So let's jump over to the letter sprite, where I now have a message received here called evaluate. And the first thing that we're going to do here, so you can see that I had delete all of selected letters here originally, and I moved it over from the solve button thinking it would be more efficient to put it here. But what actually happens here is that every time that this evaluate message is actually going to be received 5 times or 6 times, including the master object, and each time it's going to delete the list. So as we're building this list, we're going to be deleting it, and in the end there's only going to be 1 item on the list, which is no good. So we cannot delete all of the objects, all of the list here, but fortunately we already deleted it over in the solve sprite. So here we are in the evaluation, and we're going to receive this each time, and each time we do it, we're going to just add the current costume name to this list of selected letters. Let's click, let's actually add a couple letters here. Let's make this one a green one, and then we'll click the solve button and see what that list looks like now. So I'm going to call up my selected letters list here. You can see, so the information is being stored here, but it's in the wrong order. The computer for some reason looked at, well, it started off with the master object and then looked at them in the reverse order that they were created in. And I'm not quite sure what that's all about, but that created a lot of problems. It does consistently do that though, so I was able to figure out a way around it. So it's telling us that the first square at the end of the list is B, and the next one's blank, which is 0. And the next one is O with a 2 on it, which means it's yellow. And the 4th one is blank. And the 5th one is a T that has a 3 beside it. And that means, of course, that it's green. So we can keep track of the color and
the identity of each of these squares with these two pieces of information here. All right, we're going to have to do some stuff to clean up this list in a little bit to get stuff in the right order so that slot 1 is actually reflected by the information here. We'll do that in just a second though. Let me hide that list for now though. So the next thing we're going to do is we want to delete that master list item. So this number 1 here, 0, is information we don't want. That's the identity of the parent object, which of course we don't really care about because it's hidden on the side of the screen. So we're just gonna do an if statement here that says if my square ID is equal to 6, which means I'm the parent object, then delete item 1 from my selected letters list. So if I didn't do this if statement, it would delete item 1 6 times and my list would be blank again, because it's when I receive, it's being received by all the clones and all these processes are running in parallel. So we only want the master clone deleting 1 item from the list here, its own item, so delete item 1 of the list, and then we're going to build a candidate list. So the candidate list is basically the list of potential words that we're going to start winnowing down. We have a master list here, as I said, that's called common 5-letter words, and that has about 2,500 entries in it. So we're going to start deleting. We don't want to delete our master list though, because we can only use it once then. So instead of deleting from the master list, we're going to copy it over to a temporary list called candidates. And that's what we're doing right now. So we're going to build the candidate list, and at that point we're going to wait for some other stuff to happen. But let's go over to the custom block that I've created here called build candidate list. Now I told you we're using 2 different databases, so depending on which database you selected, and we're going to be able to select that down at the bottom here, there's a little sprite here that says database, and we're going to be able to click on either of these to toggle back and forth between the list of common words and the list of all words in all 5-letter words in the English language. Okay, but we're not going to deal with that right now. Let's not worry about it. So back to our candidate list building here. So we're going to be able to select whether the database is the common database or the regular database. And what we've done here is the same process, but depending on which of those buttons you've clicked, we're going to load up one of the 2 databases. So the common database is the default here, and that's going to be initialized right at the beginning. So if the database is common, we're going to go around a loop here. I've just have the letter I keeping track of my loop. We'll set it to 0. And then we're just going to repeat for the entire list of the words. So 2,500 times we're going to go around this loop. And that takes a long time, so that's one of the reasons that when we set up this custom block, we did a run without screen refresh, and that will dramatically speed up the speed at which it goes around these loops, because it's not going to have to worry about what's happening on the screen while it's concentrating on going around this list, winnowing words down. So each time it comes around this loop, it's going to change I by 1, and then it's going to add that number. Well, it's going to take that number and use it to figure out what's going on here. So we're going to add item I. So the first time around the loop is going to be item 1 of the list of common words, and we're going to take it and transfer it over to candidates. Then the next time around, we're going to add item 2, and so on, 2,499 times. So it's just going to do that and fill up this list with the entire contents of the list of common 5-letter words. If we had chosen the other option and the database wasn't common, it was the bigger database, then we would go to this else statement and do the exact same thing, except we're pulling from a different list here. We're grabbing the length of the list of 5-letter words, which is 12,000 something in this case, and then adding each of those elements to our candidates list. So now we have a full candidates list, and that has all the potential words in it. Now we have to start deleting stuff from the list. Before we do that, though, we are going to have to clean up this selected letters list here, which has 5 items on it now. The 6th item was successfully deleted here by this if statement. We're still inside. We're going to be doing all the rest of this evaluation inside this if statement, because we only want this stuff to happen once, of course. And if it wasn't in an if statement, we would run every single one of these pieces of code 5 times, once for each of the letters. So I've created a custom block here called cleanup list. We're going to drop it inside here, and it'll only run once, just like the rest of this code. And that is going to reorder our list. It's not really that complicated. Let me show you the code here. So all we're going to do is so we've got item 5 of the list, which is going to be our new number 1 here, right? So I'm going to take item 4 of the list, the one before it, and add it here. Then I'm going to take item 3 and add it down below there, and then item 2 and add it below there, and then item 1 finally, and add it to the bottom of our list. So now we have an incorrect list for the first 4 items and a correct version of the list from item 5 on down. So at that point we can just go around the loop 4 times, and each time delete the first letter from the first entry from this list, and do it 4 times. And eventually you can see as we delete stuff from this list, the next one that needs to be deleted will move up the list. And so all we have to do is delete item 1 4 times in a row, and we've gotten rid of the first 4 items on our list here, and we should be left with a list of the proper 5 items in the proper order. So this is all set up to run properly now, so let's give it a try and see what happens here. So let's click the solve button, and you can see now we have a list that actually has B in the correct spot and Y in the correct spot. It's remembering that it's wearing that costume. Let's put one in the middle spot here. We'll put a D here. Actually, let's put an O here as well, just for fun, and we'll click solve, and you can see here we have B, O, D, space, and then Y. Now that our list of selected letters is properly organized, we have all the information we need to start solving the puzzle. So the next step is to go through these word lists that I've created in the candidate list and start deleting things that don't match the information in the letters we selected here. So we're going to start with green, which is the easiest one. So in this case of this example here, we're looking for every word in the English language that doesn't have a Y at the end, and we're just going to delete it, which is of course going to get rid of a whole ton of words for us. So in order to do that, we're going to have to basically run through a loop here where we're checking through each of the letters in the selected letter list and check it to see if it's green. So we'll check the first one and just keep going down the list here until we find a green one, and then we can start deleting. So let's go ahead and do that with a custom block. So right here in the evaluate loop, we're going to add a new custom block here. I've got a bunch of them pre-made here. Let's start with the green one though. So we're going to remove words that don't match with green, as I just described. So let's have a look at the code for that. We're again going to use I just to count the number of times that we're in a loop. So we're going to be going in a loop 5 times through each of these letters. And with each letter, when we get a hit, when we get one that's green, then we're going to go through all the letters of the alphabet, which means that we need a second little variable, and we're going to call it J, to keep track inside this bigger loop of another loop, which is going through all the words in our word database. So let's have a look at the code here. So we're setting our initial variable to 0, and again going through so this is the same routine we've been doing all through here. We're just going around a loop, keeping track of the number of times by changing I by 1 every time we go through it. Very straightforward. All right, so here we go. If letter 2 of item I of selected letters, so the first time we go through this loop, it's item 1 of selected letters. So that's going to be the first item on the list, which is going to say B2. So if letter 2 of that list item is equal to 3, and it's in this case it's 2, it's not. So it's going to ignore that, go around the loop 4 more times until it finally gets to the 5th element here, the 5th element, which is Y3, right? So in that case, the if statement is going to come out as true. So if the second letter of the 5th item on the list is 3, and it is 3 in this case, then we're going to start going through the alphabet here. So we're going to set our new counter, or J here, to 0, and we're going to repeat the length of the candidate list. So we're going to go around this loop the number of times that equals the length of the list here, and each time we're going to change J by 1. So we're just keeping track of how many times we've been through the list, and we'll start at the first word. And what are we looking for here? So let's dig into this embedded comparison here. So we're looking for something that's not equal to something. So item J of candidate, so that word. So if letter I, remember I is now 5, we're the 5th time around the loop. So if letter 5 of the word we're looking at here is equal to, we want to generate a Y here, if it's equal to Y. So if letter 5 of the word we're looking at is equal to letter 1 of item I of selected letters. So that's going to be the first letter, and in this case we're with Y again, item 5 of selected letters. So looking at our list, so letter 1 is going to be Y from this list here. So we're really asking if the word in the English language, if the 5th letter of the word we're looking at here is equal to a Y, and then we're doing a not. So if it's not equal to Y, then we're going to delete that word from the list here. Okay, so let's go ahead and run that code and see how it works here. I'm going to blank out the other letters here just so that we can do our little experiment with the letter Y. It actually doesn't matter because it's going to ignore the yellow blocks anyway, but just for the sake of tidiness, let's do that. So we'll go ahead and run the program now, solve. Now we're not showing our list yet because we haven't gotten to the point at the end where it shows the list, but let's have a look at our candidates list now, and we'll see that we're down to 220 words. And if we look through these words, you can see in fact that all of them do end in Y. We're starting with A words, B words, and there we go, all of them end in Y. That works beautifully. Okay, so our green letters are working beautifully now. Now we need to look at our yellow letters. They're a little bit more complicated because it's actually a 2-step process, and I'll explain it as we go along. First of all, we want, because yellow signifies letters that are in the word but in the wrong place. So let's start with the first part, if they're in the word. So that means by extension that words that don't contain that letter are going to be removed from our list. So our first time through here, we're going to remove words that don't match with that yellow color. As I said, that's not the entire story here, and we'll get on to the next part in a second. But for now, we do know here that every yellow letter is a letter that must be found in our winning word. And so that's what we're looking for here. Let's go down to our custom block where everything is identical. There's really nothing changed here except for this evaluation line here, where we're comparing the letter that we found, that we're looking at, the yellow letter, with words in the English language. And what kind of comparison are we doing here now? We're looking for item J of candidates does not, and we've got a not here again. So if our word doesn't contain letter 1 of item I of selected letters. So remember, that's the letter we're looking at here. So if our yellow letter, so if the word we're looking at here does not contain a yellow letter, then we're going to delete that word, item J of candidates. So the only real difference between this code and the code for green is that in the green, we're looking for a specific letter slot inside the candidate word, right? We were only looking at the 5th letter or the 3rd letter in this case. With the yellow here, we're looking at the entire word, and it doesn't really matter where it is, at least for this first pass through. Let's test this out now. So we're going to try and find words that, let's look for words that contain a combination of vowels here. So we're going to look for words that have an A and a Y in them. So when we click solve, we're going to remove all the words that don't have either an A or a Y in it. Let's look what we come up with here. We're down to 104 words. And yes, many of them start with an A and end in a Y as you'd expect. But there are some other examples here that have an A in a different slot. And we'll probably find, yeah, here's some words with a Y in the beginning slot. There we go. Beautiful. Okay, so we're not done with yellow yet. As I said, things are a little bit more complicated. There's one other piece of information that this letter A denotes. So we know that there's an A somewhere inside this word, but we also know that it's not in the first slot. Otherwise it would be green, of course, right? So now that we've gone through and removed all the words that don't contain A, we need to go through and remove all the words that do contain A in the first slot, and that means we're going to take this list here and remove all of these words here that start with the letter A, and there's quite a few of them, right? That'll winnow down our list, and once we get through the letter Y as well, you'll see we'll be left with very few words. So to do that, we need another custom block. This one's going to be called remove words that match with yellow. So it seems a little strange here that we're looking for words that don't match, and now we're looking for words that match, but we're going to pretend yellow is a green tile basically. So let's go down and have a look at the code, and as you can see, everything again is identical to the other blocks that we've set up here, except we are evaluating it a little bit differently. So let's have a look at the code, this code for evaluating it. So we're looking for letter I. So in the case of letter, of the first letter here, A, we're looking at letter 1 of the word that we're looking at. So we're looking at only the first letter in each of the words in this list, and we're seeing if it's equal to letter 1 of the item on our list, on our selected letters list, which of course is A. So we're saying, so does the word start with A is what we're looking at here. And so again, that's going to generate a much smaller list for us. So let's try solving, and we'll show our list again. So now our list is winnowed down to 78 words, all of which don't start with A and don't have a Y in the second spot. We could try a Y in the last spot as well and winnow the spot down even further. Let's say, and this does occasionally happen in Wordle, that you know the spot where, you know, 2 spots where a word definitely isn't. And let's see what that brings our list down to now. Yeah, and we're down to 20 words now. All right, so you can see as we start to add more information, that list is going to get smaller and smaller until it's pretty obvious what the answer is. Okay, so there's one other kind of square we haven't dealt with, but it's a little bit more complicated, and that's our gray squares, right? So gray squares are words that have been ruled out of the puzzle. Now you can have a lot of these, and I'm not sure what mathematically, theoretically you could have as many as 21 of these, assuming that you get your 5 green letters. There's 21 letters of the alphabet left. Now I don't think you could actually play a game where you had 21 gray letters, but we do need certainly more than the couple of slots that are left over here. So that's why I've created a separate extra little bit of the interface here where we're going to enter gray letters only, and we're going to be able to enter a lot of them just to make sure that we have enough room for the number of gray letters that we're going to go through here. So, and the gray letters are words again that do not exist at all in our list. Before we do that though, so let's generate a list of blank tiles just like we have here. They're going to be smaller and they're going to be in a couple of rows, so we have some room here to do that. So just like with our white squares, our gray squares are going to involve 2 different sprites. One to appear in the main game menu, and then a sub menu that shows up letting us pick letters of the alphabet. So our 2 sprites both look the same, they just have gray tiles in them along with a final tile here called blank. And so one of the sprites is called gray letters, and the other one's called gray menu, as you'd expect. Okay, let's start with gray letters. So when the program starts, we're again going to stamp these guys with a unique ID. We're calling it gray ID, and again, that's a local variable. Gray letter selected is the variable that's going to keep track of which one we clicked when we click on a specific letter to select it in the gray menu. We set up a start location here, and we switch to the default blank costume, and then we go to a custom block here that's again going to draw a grid. So we're drawing a very big grid here. It's going to be 7 squares across and 3 rows deep, which will again encompass 21 letters, and that's way more than we need, but I thought better safe than sorry in the design of this. So the code here should be fairly familiar if you were paying attention during the earlier parts. We're doing an inner loop here of 7 squares being generated, and then going down and back to our starting position and doing the next row and the next row 3 times to generate 21 squares. At the end, we set gray ID to 0 so that our parent object, the invisible square that we're not going to use anymore, is hidden, and then we hide everything else. Okay, So let's give this a look now. We'll click the green flag and see our lovely grid being generated here. Now, as with the white tiles, nothing else is going to happen here until we click on something. So when we click on any one of these squares, let's see what happens here. When this sprite is clicked, we're going to play a sound, of course. Now we have a different variable here called previous letter that we're saving, and so as soon as we click on it, if there is a letter here already, it's going to get saved to that variable previous letter, because of course you can click on a letter after you've selected it to blank it out again if you want to do that. So that previous letter is going to be important, because in a second we're going to be generating a list of all the gray squares that have been selected right across this entire menu. And when we want to delete items, we need to know what used to be there rather than what's there right now. So it'll make more sense as we get into it. So we broadcast a message called gray menu, and then hide all of these sprites again, and then we go over to the gray menu, where again we generate a game board here. So when the game is started, at the beginning here, we're going to, and here's where this list comes in, delete all of gray letters. So we have a list here called gray letters. And sorry, I'm Canadian, and I see both spellings of the word gray with an EY and an AY, and I sometimes use them interchangeably. So sorry if that's not consistent in the project here. I'm sure you guys can get over it though. So here's my gray letters list. It's empty right now, and at the very beginning, that's the first thing that happens, is it gets deleted and it's blanked out. We also take that gray letter selected variable and make sure it's at 0 at the beginning, so we're just initializing that variable, making sure the costume is blank at the beginning, and setting a start position for our new grid that's going to appear when we click on one of these letters here. And again, we're just creating a bunch of clones here. So these ones don't need IDs because they will know who they are when they're clicked on. When you click on a specific guy, all it really cares about is what costume it's wearing when it's clicked. So we don't need to set an ID here, but we're just going to do a grid of, we're going to want to do the whole alphabet. So as we did with one of the white tiles here, we're going to do a row of 10 here, and then go down to the next row and do another row of 10 with the second repeat. And then for the last 6 letters, because we still have 6 letters left in the alphabet, we do another loop and switch those. And then the last item that's left, the 7th, is going to go next costume, and it'll show the blank. So we will have a blank one there. We can leave that visible now because we can actually use the parent object to function in that role now, and so we don't have to hide it the way we did with the white tiles. Okay, so we're ready to give this a little test here. Let's maximize the screen here and click one of these gray squares, and you can see that my alphabet list gets generated exactly the way that I want it to, with a gray square at the end, and that's again my parent object. This menu again we're going to clean up in a little bit, so don't worry if this doesn't quite look right yet. Okay, so now when we click these guys, then we need to do some other stuff. So we're still inside the gray menu object here, and when the sprite is clicked, we're going to set gray letter selected. So we're going to take that global variable gray letter selected, and we're going to match it to the costume name of whatever we clicked. So if we click on a V, for example, that will make gray letter selected V. And then we're going to take that letter V and add it to this blank list called gray letters. So here's where that previous letter variable comes in. If we end up clicking on the gray slot here, what it's going to do is look and see what the letter was before we clicked on the white, so the letter we're trying to erase, and then it's going to erase that from the list. Otherwise, it's going to add to the list here. So if the letter I've selected is blank, is the costume called blank, then we're going to delete item number of previous letter. So it's looking inside the list, looking for that previous letter in the list of gray letters. And then it is going to delete that one letter. So this is basically a formula for erasing one letter if we click on blank. If we do click on a letter though, we want to do the same thing. We want to delete the last letter that occupied that slot in case we're changing it to a different letter. And then we're going to add that gray letter selected to our list of letters here. Okay, so let's have a look at how that works here. We'll show our gray letter list here, and let's just restart the program here. I'm going to click on one of my gray letters, and I'm going to make it an F. And you can see F gets added to the list here. And let's pick another one. It doesn't have to be the next one over. Let's pick one down here, and we'll make that a Q. There we go. And let's try blanking one of these out. So I'm going to click on the Q now, and I'm going to click a blank, and you can see that now the Q is removed from the list. So we can start adding as many letters as we want. So now that we have our list of letters generated, we can go ahead and evaluate our list of words and figure out which words don't contain these letters. We're back inside our letters sprite, and we're looking at the block here that's labeled evaluate, and you can see that there's one last red block we want to add here, which is remove words that match with gray. It's not too different from the other ones. We're just again winnowing down the list, comparing it to our short list of gray letters that have been selected. So we're going to go through this the number of times that matches the number of gray letters in our list. We're going to, so we've got an I and a J variable here, and we're going to change the I by 1 every time we're going through here. So we're just fishing through this list of gray letters, and then inside of that, and for every item on that list, we're going to run through that entire list of candidate words. And what are we looking for this time? So we're checking to see if item J of candidates, so that is the particular item we're looking at. We're looking at each word on the list. So if the word we're looking at in this moment contains item I of gray letters, which is basically the letter that's saved on the list there. So if it contains that letter, then we're going to delete that item from the list. And again, we're going to move backwards through the list 1 here so that we end up going through the right number of times. Once we delete that, we're going to end up having too few items on our list, and we can end up skipping an item because when we look on the next item on the list, we're actually going to jump 2 ahead on the list because we've deleted 1. So that's why we go backwards 1 here. And I don't think I explained that earlier anyway. So anytime you delete something from a list, if you're proceeding through it, you have to go backwards 1, because what used to be 11 is now occupying slot 10, and we still want to look at what's in slot 10, if that makes any sense to you guys. Okay, and that's all there is to it. So again, we're going to be winnowing down this list and seeing what's happening. We can go ahead and hide our gray letters list here because we know that's working properly already. All right, so let's give the program a little test here. You know what we can do here? Let's get rid of all the vowels except for 1. So I'm going to grab my A, E, I, and O. So we know that the only vowel available to us now is U. So if I click solve now, we can view our candidate list and come up with a list of words that only contain the letter U. And you can see that we have 87 words here. Beautiful. Okay, now we can use these in combination with these other tiles as well. So let's build up something a little bit more complicated here. So let's look only for words that start with the letter D. And have the letter C somewhere in them. And it doesn't matter, it does matter where I put it. So there probably won't be a C here. So imagine I put a C here. We'll make this a yellow C. So there we go. So let's find words that contain the letter C, start with D, and only have a U as a vowel. Let's solve. And again, we'll show our candidate list. And yeah, we're left with 3 words: ducks, ducts, and Dutch, all of which start with D, all of which contain the letter C in the 3rd slot here, and all of which have no other vowels in them. Okay, so this is pretty much ready to go. We just have to clean up a few interface elements and get this looking pretty, and then we'll be done. So one quick thing I want to do here is let's finish off the code on our solve button. You remember that our candidate list isn't popping up the way that it's supposed to be. So after we're done evaluating, this code has been waiting for us to finish evaluating, and we're actually done the evaluation part of the code now. And so we're going to jump back to this spot again, and we're going to get our solve button to actually tell us how many solutions we've found. So our candidate list has been winnowed down, and we now know the length of the list. So in this case, our candidates list only contains 3 words. So if we call up the length of the candidate list, you see it'll call up the number 3. So I'm going to say, have the actual button talk and say 3 possible solutions found for 2 seconds. It'll pause there long enough to get you to read that, and then it'll show the candidate list. So we've got this variable here called list visible, and that's going to flip back and forth between 1 and 0. And that's going to be controlled by this other button here called show list. Let's jump over there right now. You can see that I've got lots of code here in every one of these blocks with shows and hides, and they're all basically variations on the same thing. Some of these menus need to show when the main menu is showing, some of them need to show when the gray menu is showing, and some of them need to show when the white letter menu is showing. And so I've got different blocks here that that simply do a show or a hide on each of the sprites here to make sure they only show up in the appropriate place. All right, so when we click on that sprite to show list, if the list visible is equal to 1, so if it's already visible, then we're going to hide the list when we click this and set that visibility to 0. And if it's not visible, we're going to show it, and we're going to set the list visible to 1. And so this is a simple toggle kind of script that we use a lot for on-off buttons. You need a variable to keep track of its status, and this way we can show and hide that list anytime we want to. But we also want the list showing up automatically when we click the solve button, and that's already been coded now, so let's give that a try here. We'll click solve, 3 solutions found, and there you go, and then the list appears, and we'll hide it with the hide list, and then we can change our information. We'll look for things that contain the letter T and solve again, and now we're down to 1 word here. Beautiful. We'll hide the list, and we'll go cheat at our Wordle puzzle, and then that will be it. Okay, so there's a couple, as I said, a couple more interface elements that need to be cleaned up. As I said, we're going to go through all of the blocks here and make sure that they're all showing and hiding in the appropriate spots. We've got a menu screen here that I haven't shown you yet that just makes things look a little fancier. You can customize this if you want to. So we've got one screen here for the white menu, for the white letter menu, and another one for the gray letter menu. And the code for that, again, is just making it show or hide. We're doing it a little fancier though, so we're going to have these menus fade in and fade out using ghost effects here. So you can look at the finished code if you want to have a closer look at what I've done here. There's one last button here. Oh, we have the main title for the game here, and that just has a bunch of show hides. Let me show them to you, but really it's just, so we've got a couple of different circumstances. The start of the game, when my main menu appears, when my main menu hides, when my gray menu appears, and when my gray menu hides. And every single sprite in the game, as I said, is going to need that kind of code on it. I've got a tutorial here, and I'm not going to go through that because that's kind of out of scope here. I do want to show you the database sprite here. So I've created a little sprite here that shows, it lets us choose between common words and the bigger database of 12,000 words, which in practice you're not really going to need to play Wordle, but I just wanted to show you an extra function here. Let me show you how that works. So when this sprite is clicked, we're just going to toggle back and forth. It looks like there's two buttons, but really it's just one big button that we can switch back and forth between these different states. So no matter where we click, we're just going to go back and forth between this one being selected and this one being selected. So again, we're toggling with this. So we're going to set a variable here called database as the global variable, and we'll set it either to all or to common, depending on what we've clicked, and we'll wear the appropriate costume so that we can control that. All right, let's take this for one more spin and see how using the two different databases will change our results here. So I'm going to start with a letter P. We'll make it green, and let's eliminate some vowels. So I'm looking only for words that don't contain an A and don't contain an E, and have a U somewhere in them, and we'll say not in the last spot here, but we'll make a yellow U here. Okay, so let's try solving our puzzle here. So we found 9 words using our common word database. And yes, they all start with P, they all contain the letter U, and they don't have an A or an E in them. Beautiful. So let's hide that list now and try looking at the all words database and see how many more than 9 we're going to get here. So now we found 85 words, so which is quite a bit of a bigger list to look through. And again, you're seeing here that we've got a bunch of words that we really don't care about. We're never going to use a word like pluk or poof. Now there are some words here that I see on this list that probably might be Wordle words, like, well, not plural words. You'll never find words like plums in the list here, but you might find a word like pinup, and you might find a word like pouch, for example. So it might be worth your effort to look at that bigger database if you want to. I've just simply given you a choice here if you're trying to winnow down. Sometimes when you're playing this game, you can end up with lists of hundreds of words, and that's not particularly useful. So every once in a while, winnowing down this list is pre-selecting words that are common is usually a better way to go. Though I did want to give you the option to look at the bigger list. Okay, so if you just always want to work with the bigger list, if you're finding this a problem, you can just remix the game and get rid of this if-else statement here. And I would just get rid of this button. I'll just delete this sprite entirely and just put the contents of the else statement right here, and that will make sure that we're always working with the more complicated database. 85 solutions. Okay, that worked fine. Well, there you have it, a really sneaky way to cheat at Wordle. So you can adapt this to almost any word game, as I suggested at the beginning of the tutorial. You could definitely use this as a crossword solver, for example, as well, though you're going to need to update your list with a list of all the words in the English language as well, and you're going to need to do some modifications to the code. But I think with a little bit of creative coding, you could adapt this approach to almost any word game. So if you do remix this game and make something cool, please share it with me. I might show it on my live streams, which air every Saturday at 10 a.m. In the meantime, happy coding, everybody, and we'll see you next time. This tutorial was produced by Chromeworks Technology. For more Scratch tips, tutorials, game reviews, and interviews, subscribe to this channel and make sure to tune in to our weekly live show, Saturdays at 10 a.m. Eastern on YouTube.